It is a miracle. That was frozen 24 years ago and implanted now successfully.
What's the longest time you've slept for? Well, for many people, the answer is in hours or at the most days. Scientists have revived for the first time a human that slept for 24 years. How did this person sleep for so long, and how did scientists manage to rouse the person from deep sleep? We bring you the details as we dive into the story of the first ever person to be revived after 24 years of cold sleep. Many people know the romantic story of Sleeping Beauty, who slept for a long time before being awakened by the kiss of a charming prince. Just how long she slept is not officially known. However, common theories say she slumbered for a century. While that is still a long time to sleep, Sleeping Beauty was not real. However, the record for the longest sleep is still impressive. Ryota Murata, the sleeping record holder, is a former professional boxer who competed from 2013 to 2022. He held the WBA middleweight title twice and was the first Japanese boxer to win an Olympic gold medal and a world title in the same weight class. But more interesting is Murata's unusual sleeping habits, which he claimed helped him recover from his intense training sessions. Murata's record of sleeping was impressive and sometimes baffling. He once slept for 20 hours straight after a fight and often slept for more than 10 hours a day. He also slept on the floor without a pillow or a mattress because he believed it was good for his posture and blood circulation. He even slept on the floor of his hotel rooms when he traveled abroad for his bouts. Murata said that sleeping was his secret weapon, that he felt refreshed and energized after a long nap. He also said that sleeping helped him cope with the pressure and stress of being a professional boxer. He did not have any specific routine or ritual before going to bed except for drinking water and brushing his teeth. He said he could fall asleep anywhere and any time as long as he was relaxed and comfortable. Murata's record of sleeping was admired by many fans and fellow boxers who wondered how he could sleep so much and still perform at a high level. Some even joked that he was a sleeping giant or a sleeping beauty. However, Murata also faced some criticism and skepticism from some experts and commentators who questioned whether his sleeping habits were healthy and beneficial for his boxing career. Some argued that sleeping too much could affect his metabolism, immune system, and mental alertness. Murata retired from boxing in 2022 after losing his WBA middleweight title by technical knockout in the second round. He said he was satisfied with his achievements and grateful for his fans' support. He also said he was looking forward to spending more time with his family and pursuing other interests. But will Murata continue his record of sleeping or change his sleeping habits now that he's hung his gloves up? Murata didn't say. However, how much sleep does a normal human need to be healthy? If you're like most adults, you probably don't get enough. Sleep is essential for your health and well-being, but many people struggle to fall asleep or stay asleep for the recommended amount of time. According to the National Sleep Foundation, the average adult needs about 7 to 9 hours of sleep per night, but this may vary depending on your age, lifestyle, and health conditions. Some people may need more or less sleep than others depending on their individual needs and preferences. However, getting too little or too much sleep can have negative effects on your mood, energy, concentration, memory, immune system, and overall health. Therefore, it's important to find out what works best for you and stick to a regular sleep schedule as much as possible. However, there is another human out there that set a record for even a much longer sleep, lasting at 24 years. Emma Gibson was conceived in 1992 but did not arrive on the scene until 2017. When the New York Times published an article about cryopreservation in 1974, experts imagined a library of one-day-old frozen embryos guaranteed free of all genetic defects with sex, eye color, probably IQ, and other traits described in detail on the label. Simply defrost and insert. But no one anticipated how much technology would someday distort time, culminating in births like Emma's. Initially, embryos generated through IVF were inserted in the womb immediately. Louise Brown, the first IVF baby, was born in 1978. It took another 6 years for doctors to develop the freezing and unfreezing process. In 1984, Zoe Leyland, the first infant born from an embryo frozen during IVF, was born in Australia. The embryo had been frozen for 2 months, which we today regard to be a short period of time. Doctors in the United States, the United Kingdom, Israel, the Netherlands, and West Germany swiftly adopted the procedure, and more than 24 babies were delivered from frozen embryos over the next 2 years. The capacity to temporarily pause time provided practical benefits. Previously, embryos had to be implanted all at once or discarded. Now excess embryos can be preserved for later use, lowering the likelihood of twins and triplets. Doctors may wait until a mother's body is ready to accept an embryo. And as predicted, the extra time was finally used to examine embryos for genetic illness. However, actual designed babies are still a long way off. Now, Gibson, who was born on November 25th, was frozen as an embryo and transferred to a faith-based facility in Knoxville that specializes in embryo donation and adoption, according to doctors and her parents. Her mother was at 25 years old and said she could have been best friends with her daughter if the baby had been born when it was supposed to be born. Emma's father, Benjamin Gibson, said in a statement, "I think she looks pretty perfect with being frozen all those years ago." Emma would have been conceived a year and a half before her mother, Tina Gibson, was born. Now, some people tend to confuse frozen embryo babies with IVF babies. Frozen embryo kids are conceived from embryos that have been frozen and saved for later use, whereas IVF babies are conceived from fresh embryos that are transplanted to the uterus shortly after fertilization. Both are types of assisted reproductive technology, ART, that aid couples who are having problems conceiving naturally. The birth weight of frozen embryo kids differs from that of IVF babies. Frozen embryo kids are bulkier and have longer gestation durations than IVF babies. The variation in the uterine environment between fresh and frozen cycles, according to the researchers, could explain this. The uterus in fresh cycles may be driven by hormones and medicines that alter embryo implantation and development, whereas the uterus in frozen cycles may be more natural and receptive. The health results of frozen embryo babies and IVF babies are another distinction. Some studies have revealed that frozen embryo kids have a decreased chance of certain issues when compared with IVF newborns, such as preterm birth, low birth weight, and congenital abnormalities. This could be due to the fact that freezing and thawing embryos select the most viable and robust ones, whereas fresh embryos may include others that are less healthy or genetically aberrant. Other studies, however, have revealed no significant difference in pregnancy rates, live births, miscarriages, or neonatal mortality between frozen embryo kids and IVF newborns. As a result, additional research is required to confirm the long-term health impacts of frozen embryo transfer. The risks of frozen embryo babies all occur during the thawing out of the embryo. If an embryo survives being thawed out, it has the same chance as any other embryo of resulting in a successful pregnancy. Furthermore, there is no evidence that frozen embryos, regardless of age, increases the incidence of birth abnormalities. The National Embryo Donation Center, NEDC, in the US exists to save frozen embryos from destruction. There are no standard figures on the number of frozen embryos in the United States, but the NEDC and other organizations believe that it could be as many as 1 million. People who freeze embryos for fertility therapy frequently wind up with more embryos than they need for pregnancy. They must select whether to preserve them for later use, usually at a cost, to dispose them, donate them for scientific research, or to donate them to a clinic such as the NEDC. The non-profit clinic is funded by the government and does not charge donors, but it does charge embryo recipients. Now, the Gibsons, according to the doctors, were nothing out of the ordinary. It was a routine fertility story, only made more interesting by the long time the embryo remained frozen. 2 embryos were transferred to Tina Gibson, but she only had 1 baby as a result, but that is quite normal as not all embryos survive. In media interviews, the Gibsons stated that they were seeking an embryo whose parents resembled them. They weren't seeking to break any records when it came to having a child. Individuals and couples tend to select sperm, eggs, or embryos with features similar to their own. These include physical characteristics such as height and weight, hair color and eye color, body build type, as well as, of course, race, often religion or cultural background, education, physical activities, and other talents and activities such as being interested in music or art or being mathematically or scientifically inclined. Basically, reproduction is a pretty personal thing. But how long exactly can you freeze an embryo and it remain viable? According to fertility doctors, the answer might be indefinitely. Embryos, a set of cells that mark the earliest stage of human development, are frozen and maintained in liquid nitrogen at -320 degrees Fahrenheit or -196 degrees Celsius, a temperature that ceases all biological activity. And if all biological activity has stopped, you've essentially hit the pause button, and things should resume when you remove the pause button. Even if an embryo is frozen for decades, it will continue to grow naturally once thawed out and implanted. However, while there is no biological limit to how long an embryo can be frozen, there are extrinsic elements that can harm the embryo. The sun's ionizing radiation arguably puts some sort of limit on the indefinite lifespan of the frozen embryo, since it can induce minor mutations or damage to the cell's DNA. Except for lead, the radiation can pass through any material, including the massive stainless steel or aluminium thermoses used to store frozen embryos. However, specialists believe that it would take hundreds of years or a number of lifetimes for this radiation to substantially harm the viability of the embryo. The discipline of embryology and freezing procedures have both evolved significantly since the 1980s, when experts first began preserving embryos. Embryos were formerly frozen using a slow freezing process, but are now frozen using a very fast freezing procedure known as vitrification. Furthermore, embryos are now frozen at a later developmental stage when they are more robust. Previously, embryos were stored when they had 2 cells or 6 to 8 cells, but currently they are preserved when they have roughly 100 cells. Meanwhile, scientists continue to investigate cryonics to see how it can be applied to humans. Cryogenics in itself is a simple thing. It is the study of how materials behave at very low temperatures. This topic of study assists us in comprehending the molecular changes that occur when a substance reaches the lowest attainable temperature of -273 degrees Celsius. This expertise is currently being used in the realm of death care, as human bodies are being frozen in the hopes of reanimating them in the future. Believe it or not, around 350 people worldwide have elected to have their bodies frozen soon after death. However, if the cryogenic process is to take place, a lot of documentation must be completed long before death. Clients must submit all required papers and ensure money is in place well in advance. After a person is deemed legally dead, the freezing process must begin within 2 to 15 minutes. The body is then encased in ice and injected with drugs to prevent blood clotting. A heart-lung resuscitator is a specific machine that artificially restores circulation and breathing. After that, the body is taken to a long-term care facility for ultimate chilling and perfusion, a process in which the patient's blood is slowly and carefully replenished by special substances to prevent ice formation. They are then progressively cooled to -196 degrees Celsius and kept in liquid nitrogen in a special storage device known as a cryostat. And cryonics advocates claim that there are more examples of life that have been frozen and reanimated. Insects, vinegar eels, and even embryos that later became human children are among them. And recent biological advances give us optimism that humans will be able to accomplish even more in the future. We already know that reducing body temperature can sometimes save victims of cardiac arrest. Who's to say we couldn't use it to help even more people in the future? Now, there are popular myths and misconceptions about this procedure, but here are the truths about the service or process. For example, you will be completely frozen. Although the cryonics procedure does require significantly lowering your body's temperature, it is not the same as just tossing something in the freezer. Chemicals injected into your cells by a process known as vitrification protect tissue and organs against freezing. The idea is simply to halt all molecular activity so that the organisms can be retained in its natural form. Also, this procedure is only for the deceased. We now understand that death is not a sudden occurrence. In reality, it is a protracted procedure that occurs in stages. A person is deemed dead when his or her heart stops beating. However, living processes continue within cells and tissue until they eventually stop and disintegrate due to a lack of oxygenated blood. In cryonics, before this progressive degradation can begin, the patient is stabilized. Tissue and organs are kept alive artificially in the same way as cardiac arrest patients are maintained alive. However, there is also the legal aspect of the procedure. The fact is that there is still a lot of work to be done to ensure cryonicists' legal rights. In most states, the next of kin has the authority to decide what happens to a deceased loved one's body. Even if the deceased person had a legal contract with a cryonics facility, their wishes are frequently overruled by family members who want to bury or cremate them instead. Representatives of cryonics institutions, on the other hand, are persistent in going to court to argue for the rights of persons with whom they have legal obligations. They can even file an injunction to prevent an autopsy in many situations. And of course, we can't run away from ethical concerns since many remain unanswered due to the method being new. For example, if the cryonic center runs out of funds or the technology fails, does it still owe it to the patients entrusted to it? And on a more existential level, can all the complicated components of a person's actual identity be preserved? If someone is successfully reanimated in 30 years, will they be able to operate as their actual self in a society that will undoubtedly be vastly different from what they remember? All of these are issues that the cryonics community must still address. However, if you still wish to maintain your body after death for future resurrection, where do you turn? If this approach appeals to you, there are several renowned American organizations to look into. The first is the Institute for Cryonics, which has the edge of having a high degree of stability. According to its website, the Cryonics Institute's objective is to give the finest possible quality at the lowest possible cost. They are dedicated to serving their members as a non-profit organization. The Institute believes passionately in the prospect of a drastic extension of the human lifespan, providing patients with a second chance at life, youth, and health, as described in Robert Ettinger's 1962 book, The Prospect of Immortality. Robert Ettinger, the scientist credited with founding the cryonics movement, launched the Cryonics Institute in 1976. Ettinger rose to prominence following the publishing of his book. He appeared on talk shows and spoke with newspapers and publications on the subject. And thanks to the work of researchers Greg Fahey and William F. Roll, vitrification became a part of the cryopreservation process. Since its inception in 1976, the Cryonics Institute has cryopreserved a total of 100 patients, all of whom are currently alive and well at the facility. The Cryonics Institute is owned by a system of membership-owned, controlled by a board of 12 directors, all of whom have a personal love for the principles of immortality that cryonics embodies. They have created a quick and efficient approach that combines the greatest parts of emergency medicine and mortuary care. And they have teams of funeral directors that have received particular training in the science of cryonics. When their skills are urgently required, these highly skilled and competent teams can be dispatched anywhere in the world. Another leader in the cryonics field is Alcor. Alcor is a non-profit organization headquartered in Scottsdale, Arizona. They specialize in cryonics research and technology and were founded in 1972. Members can use life insurance to cover the expense of cryopreservation. Alcor is currently developing technology to retain the information in the brain, which includes memory and identity. Alcor had 177 patients under its care as of the end of 2019. There are 129 male patients and 46 female patients. Their first suspension occurred in 1967 when Alcor was still known as the Cryonics Society of California. The most recent was a 77-year-old man who had been an Alcor member since 2000. Since Alcor's inception, the number of patients under cryonic suspension has constantly increased. So how much does cryopreservation cost? Cryonics can be prohibitively expensive, as it is far more expensive than other death care choices. The Cryonics Institute costs a one-time fee of $28,000, which is often covered by life insurance. This price includes both storage and vitrification perfusion. Alcor charges $200,000 for whole-body cryopreservation, which is also covered by a life insurance policy. For only $80,000, the patient's head can be preserved alone. But are cryonics patients still alive? This is a difficult subject because there are several definitions of dead. The cryonics process cannot begin until the patient is legally dead according to the law. A medical expert usually deems someone legally dead if they stop breathing, their heart stops beating, or their brain activity stops owing to the withdrawal of life support. However, the cryonics theory holds that we will one day be able to resurrect these individuals. And so breathing and blood circulation are immediately restored after legal death to ensure that vital organs continue to operate. As a result, cryonics patients are not regarded to be dead. The term cryopreserved is used instead. So when does the procedure begin following death? The cryonics procedure should ideally begin as soon as the heart stops beating, usually within 1 or 2 minutes and no more than 15. If it takes longer, the repair process may become more difficult. This is due to the fact that any deterioration of the circulatory system can make it more difficult to circulate the chemicals required to avoid ice formation. And what are the chances that this will work? Well, there is a lot of data to suggest that cryonics could work someday. Based on what we know about tissue regeneration and molecular repair, it appears that every patient will be able to fully heal from any damage in the future. However, there are no promises about how much of the patient's memory and personality will survive the cryonics treatment. And here is the big question: has anyone successfully revived following the procedure? As of this video, no human has been revived after having their body temperature dropped to well below freezing. However, the objective of cryonics is to hope that technology will improve sufficiently to allow this to happen. The study of molecular nanotechnology is expected to uncover ways to undo any damage produced by the cryonics procedure. To that end, cryonics patients are cared for until they may be safely awakened. But all this won't stop researchers from working on it and investors from investing in the business model. For example, a group of architects, engineers, and scientists are building a time ship on an 800-acre tract of ground just outside the little town of Comfort, Texas, with the goal of transporting tens of thousands of people to the far future. However, their method does not entail the usage of flux capacitors or the use of light-speed travel through black holes. Instead, the time ship intends to store humans at such low temperatures that their remains are kept for reanimation by a future civilization. Just as a spaceship allows people to move through space, time ship will allow people to travel to another time in the future, explains Stephen Valentine, the Timeship Project's director and lead architect. Valentine has received multi-million-dollar funding from anonymous donors to create a mecca for cryonics and life extension, and the timeship proposes to store additional valuable biological samples such as organs, stem cells, embryos, and even the DNA of rare or threatened species, in addition to a fortress-like structure that can hold these frozen individuals. The Stasis Research Park, the world's largest life extension research facility, will also be located on the property. The entire site will be off-grid, relying on wind and solar energy to prevent future power shortages, and the location has been carefully selected to be remote from earthquakes, tornadoes, snowstorms, and any other calamity the Earth may throw at it in the next few hundred years. Valentine spent 5 years researching and constructing the site, studying pyramids, ancient tombs, bank vaults, and medieval fortifications, anything that has withstood the test of time. He's even sought advice from experts on how to shield frozen time travelers from the consequences of a nearby 2-megaton nuclear weapon. The resultant design is a massive spaceship castle hybrid with strong, low circular walls encircling a central tomb-like chamber, housing thousands of storage pods under strict security. The particular method for cooling the corpses is unknown, but it's expected that bodily fluids will be emptied and replaced with a solution that helps protect tissue against the creation of ice crystals. According to Valentine, the storage pods will employ liquid nitrogen to store the bodies at roughly minus 130 degrees Celsius and should be able to maintain low temperatures without power or human maintenance for up to 6 months. Several such developments have convinced Valentine and the affluent investors funding Timeship that properly freezing a person is now possible. A team from the company 21st Century Medicine claimed to have invented a new vitrification technology in 2015 that maintained pig and rabbit brains without obvious harm. But what happens when you defrost? Nobody knows what the world will look like in hundreds of years, but there will be significant logistical obstacles for anyone who is awoken from the grave. To begin with, all of your money, friends, and family would be long gone, and you'd most likely struggle to find work in whatever hyper-advanced society has managed to resurrect you. There are also larger concerns about how the planet would manage with a human population that lives significantly longer than it does now.